Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maharaji University, Rohtak. Today our topic will be scalar and vector surface integral, and also I will discuss our Green's theorem. Today I will cover all the three topics, and only two topics will be left in your first unit. Last two topics will be Gauss divergence theorem and Stokes theorem. So these two topics I will discuss in our next video. Right? So first thing, scalar and surface integral. Scalar surface integral and vector surface integral, right? So surface integral. First thing is surface integral. So a surface R is equal to FUV is called smooth if FUV possesses continuous first order partial derivatives, right? So you can see here that this is your surface and R vector R is equal to FUV, right? And FUV have partial derivatives, so that partial derivatives will be continuous, and these will be first order partial derivatives, right? And there is a force here. Let F vector be a vector function and S be the surface. So we need two things, a vector function and a surface, then we can make a surface integral, right? Now, surface integral of a vector function f vector over the surface S is defined as the integral of the components of f vector along the normal to the surface component of f vector. So this is your normal, n vector, n cap means this is your normal vector, right? And this is your f vector given function. Along the normal is equal to f vector dot n cap, where n cap is the unit normal vector to an element ds, and your n cap value is gradient of f upon modulus value of gradient of f, and ds is equal to dx dy upon n cap k cap. So these two value we will always use, and your surface integral is double integration f vector dot n cap into ds, and where n cap is equal to gradient of f vector upon gradient of f, and your ds is equal to dx dy upon n cap into k cap, right? Now there is an example here, so our theory will be clear by this example. Evaluate double integration yzi plus zxj plus xyk cap ijk are the directions into ds, where s is the surface of the sphere, x square plus y square plus z square is equal to a square in the first octane. In first octane, that means x in the xy plane in the positive coordinate, right? So, and your positive coordinate is your first coordinate, right? Now, f vector is equal to given yzi plus zxj plus xyk cap, right? And your surface is given, sphere is given, x square plus y square plus z square is equal to a square. So this is your another scalar function. This is your f vector is your vector function, and phi is your scalar function. So phi is equal to x square plus y square plus z square minus a square, right? Now vector normal to the surface. So we need to calculate normal vector here. So we will calculate gradient of phi for the normal surface. So for the normal, we will calculate gradient of phi. So gradient of phi is equal to grade value is I del upon del x plus j del upon del y plus k del upon del z dot phi means x square plus y square plus z square minus a square. So I del upon del x with this bracket plus j upon del y with this one, and k upon del upon del z, right? Now differentiate this bracket with respect to x, so you will get 2xi plus 2yj plus 2zk cap, right? Now this is the gradient of phi. Now n cap we need to calculate. So your n cap is, we know that our n cap is gradient of f upon gradient of modulus value of gradient of f. So calculate. So 2xi plus 2yj plus 2zk upon here the coefficient of I is 2x. So 2x square plus coefficient of y is 2y is 2y whole square plus 2z whole square. So we need know that 4 is common. So x square plus y square plus z square you can write a square. So a square, so 2 to cancelled out, a square will be outside. So your n cap is xi plus yj plus zk upon a. Now, second thing we need to calculate in surface area is f vector dot n cap. So just calculate f vector dot n cap. So your f vector dot n cap is 3xyz upon a here, right? Now, next thing ds. So ds is your dx dy upon k cap into n cap because surface sphere is a in the first octant, so our n cap will be k cap, right? So calculate k cap dot n cap. So k cap dot n cap means this one. So a into z upon a, k dot I 0, k dot j 0, k dot k 1. So z upon a will be here, a cancelled out, so your z z also will be cancelled out. So you will get your final line is 3xy dx dy. Now next thing is calculate your limits. So we know that x square plus y square plus z square is equal to a square, and we are talking about first octant only. So your z will be 0 here, and x square plus y square is equal to a square. And in the first octant, so 0 to a square minus x square, your y limit will be 0 to square root of a square minus x square, and limit of x will be 0 to a, right? So 0 to a and 0 to square root of this one, 3xy dx dy. Now next, just integrate this integral. So you will get first integrating with respect to y, so y square upon 2. So you will get upper limit a square minus x square whole square, so square root will be removed, and you will get x a square minus x square into dx here. And just simply integrating with respect to x, and after applying, so you can see that the 3 upon 8 a to the power 4 is your final answer, right? So you can see that all the integration is being here, and your final answer is 3a to the power 4 upon 8, right? So this type of question, this is your 7.5 marks question, and it can be come in your exam. So just and this is very simple. If your theory is clear about if your theory is clear about a surface integral, then you can solve your questions very easily. If your theory is not clear, then you cannot solve these questions, right? So just clear your theory, and this is very easy topic, right? The f vector is given, you will find gradient of phi scalar function, you will calculate, and after that f vector dot n cap, then ds, so dx dy upon n cap into k cap, right? If first octant is given, right? Now, there is an exercise here, 5.11, and this exercise is related to your surface integral topic. So, just solve these questions. In the question one is also in the first octant. So, your f vector, here f vector. So, here a vector is given in the place of f vector, and the surface is given. So, this is your phi, right? This is your f vector, this is your phi. So, you will calculate grade phi. After that, calculating n cap dot sorry f vector dot n cap, first calculate grade phi, then calculate n cap, then calculate f vector dot n cap, then double integration of this value, right? So just calculate, and your answer is here. I think 31 is your final answer. So just calculate this, right? And here also x square plus y square is equal to 16 included in the first octant, z is equal to 0 and z is equal to 5. So this is your also phi is given this one, and a vector is given this one, and after put everything, just find n cap dot k cap. So and the last, and double integration of this one, right? So just calculate all these terms. The f factor is, this is your phi, F vector, this is your phi, right? So all these things are given here. So you need to calculate all these things. Just solve these questions, and your answer is also here. So match with the answers. If have any doubt, then ask me. Right now, next topic is volume integral. Right, so volume integral, let F vector be same as it is as is surface integral, and surface integral, that means area we are finding, so it will be double integration, and volume, that means three directions are given, so in triple integration will be here, right? So let F vector be a vector point function and volume V enclosed by a closed surface, right? So also we need here volume and three directions and triple integration. The volume integral is equal to triple integration F vector dot dv, and dv means dx dy dz or dz dy dx, whatever, on the basis of your questions or whatever is given. Z depends on x and y, then limit, what will be the limits, what will the order of the dz dx dy, so it's depend on your question. Right now, there is an example here. If F vector is equal to 2zi minus xj cap plus yk cap, evaluate triple integration F vector dv, where v is the region bounded by the surface. These all. So limit here, limit already given. First, x limit is given 0 to 2, y limit is given 0 to 4. Both are the constant limit. But z limit is a variable limit. Z is equal to x square and z is equal to 2. So one limit is constant limit, one limit is variable limit. Constant means 0, 1, 2, 3, 4. ABC type, right? And variable limit is x square, means you have the variables in your quotients, means x, y, z are three directions and three x's and the three variables also. So one variable is depend on another one. So there will be a variable limit. Right now, triple integration F vector into dv. So F vector is your 2zi minus xj cap plus yk cap. Now dv we are writing here dz dy dx. Right now, just write all the limits here and differentiate first with respect to z. So you can see here 2I z integration is z square upon 2, x j cap, there is no z, so dz integration will be z, and y k cap dz integration will be z, and limit of z is equal to 0 to z is equal to x square. Now rule is upper limit minus lower limit. So 2z square 2 cancelled out, so it will be this one and this one and this one, and z is equal to 0 to x square dy dx. Now upper limit, so x square is your upper limit, so x square, okay, there is a mistake here, x square minus 2 whole square, right? So this term is not will not be here, it will be x to the power 4 minus 4 here, right? There is a term, there is a mistake here, x to the power 4 minus 2 square, minus 4 will be here, minus x, and x square minus 2 j cap plus y, this one, right? So just you will solve a first step and you will do it yourself, because there is a mistake here. So just solve this, and after that with respect to y integration, and your final answer is 32 upon 15 3a plus 5k. So you will integrate with yourself and by yourself, and match your answer with my answer, just integrating with respect to z first, after applying limit of z, then with respect to y, that is your constant limit, then apply, then with respect to x. So you will get your final answer, this one. Right now, there is also exercise here, and F vector is given, and limit of lower limit are given here, x is equal to 0, y is equal to 0, z is equal to 0, and for the upper limit find z from here. So z is equal to 4 minus 2x minus 2y, and for the limit of y you will put z is equal to 0. So you then calculate y, and for the limit of x you will put y is equal to 0, z is equal to 0, then you will get your x limit, right? So just find all these three limits and put here, and there is a gradient here. This is the divergence of f vector here. So you will calculate divergence of f. That means I del upon del x plus j del upon del y plus k del upon del z, bracket 1 into f vector is given this one. So you will calculate I dot I1, I dot J0, J dot J, K dot K, and del upon del x also. So differentiate this one with respect to x, y, z respectively, and then calculate dv means dz dy dx, then apply the limits and get your answer 8 by 3, right? Now second question also, phi is given, x is 45 x square y, right? And v is the, so write phi here 45 x square y, and find the limits. Lower limits are given and upper limits you will calculate, right? Now third question, del cross f you will calculate first, and then find the limits, right? Fourth question, limits are given. Z is 4 minus x square, and z is equal to 0 is your limit, lower limit, and y is equal to 0 is equal, and y is equal to 2 is your y limit is given, and for the x limit you will put z is equal to 0, so x square is equal to 4, so x is equal to plus minus 2, right? So minus 2 and 2 is your upper limit, and lower limit, limit of x, right? So you just solve all these 5 questions, and there is answer here, so match answer with your answer. Now, next topic is surface integral and vector integral. Both are 7.5 marks question, right? But Green's theorem, if Green's theorem is coming in your exam, so it will be maybe 7.5 marks question, and verification is asking, then it will be your 15 marks question. And this is very important theorem, Green's theorem, Gauss divergence theorem, and Stokes theorem. These three very important, and at least two of them will come in your exam. So it will be 90% can come in your exam, right? It may be for 2.5, maybe just ask that write the statement of Green's theorem, right? And in it is, if it is coming in your 7.5 marks question, then apply Green's theorem for this to solve this integral, and if it is 15 marks question, then verify Green's theorem, right? So there are three types of 2.5, 7.5, and 15 marks, right? So just prepare over all the three theorems. So Green's theorem is, for a plane statement, if mxy, nxy, del m upon del y, and del n upon del x be continuous functions over a region R bounded by simple closed curve in xy plane, right? So mxy and m and n both are the function of x and y here, and these are the partial derivatives, first order partial derivatives, and these derivatives are continuous functions over a region R. Then your Green's theorem statement is, integral is single integration, and this is your closed integration, m dx plus n dy is equal to double integration, R is the reason, del m upon del y minus del n upon del x dx dy, right? So your Green's theorem is going single integration to double integration, right? So if you have single integration, so you can apply their Green's theorem, and you can convert it into double integration. So, and if you have double integration, so then you can convert it into single integration by your Green's theorem, but condition will be satisfied, right? So condition must be fulfilled. That means this condition and this condition must be fulfilled, right? So proof is not in your syllabus, only applications are here. So Green's theorem in vector form, there is another form, and this is your vector form. So single integration f vector dot dr vector is equal to double integration del cross f vector dot k vector into dr. So this is your vector form of the Green's theorem, right? Now where f vector is given mi plus nj, r vector is given xi plus yj, and k cap is a unit vector along z axis, and your dr will be dx dy, right? So there is example related to Green's theorem, and a vector field f vector is given by f vector is equal to sine y I cap plus x 1 plus cos y j cap. Evaluate the integral single integration c f vector dot dr vector, where c is the circular path given by x square plus y square is equal to a square. Right? So your f vector is given here, and we need to calculate f vector dot dr vector. So in the line integral, I told you f vector dot dr vector. So dr vector is your dxi plus dyj, right? So you will just calculate a f vector dot dr vector. So sin y I cap plus x 1 plus cos y j cap dot dxi plus dyj, right? So I dot I 1, so sin y dx plus j dot j 1, so x 1 plus cos y dy. Now you can see that this function is same as it is in this in the right hand side. mdx single integration is here, single integration is here. mdx means sin y dx, so m is your sin y, n dy, n means x 1 plus cos y. So for the on applying Green's theorem, so you can see that left hand side is equal to your m is equal to sin y, n is equal to x 1 plus cos y, and you need to calculate this value, and this value is del m upon del y is equal to cos y, del n upon del x is equal to 1 plus cos y, right? That means m is differentiating partially with respect to y, n is differentiating partially with respect to x. Now, by the equation 1, so your equation 1 is m dx plus n dy is equal to del n upon del x minus del m upon del y. So del n upon del x value is 1 plus cos y, and del m upon del y value is cos y. So cos y cancelled out, and dx dy will be here. And we know that dx dy is your area of the circle, right? So area of the circle is your pi r square. We know that area of the circle, and radius is given here a. So your area will be pi a square, right? And your Green's formula is single integration m dx plus n dy is equal to double integration del n upon del x minus del m upon del y dx dy. So you are getting your answer pi a square. Right? Now, there is another example here. Using Green's theorem, evaluate this integral where C is the boundary described counterclockwise of the triangle with vertices 0, 0, 1, 0 and 1, 1. Right? So 0, 0 is in origin, at origin, 1, 0 on the x-axis, and 1, 1 will be in the first quadrant. Right? Now, by Green's theorem, m dx plus n dy is equal to double integration del n upon del x minus del m upon del y dx dy. This is your first integral. Now you can see that this is your given integral, and you can compare with left hand side. So you can get, okay, here. So you will get m is equal to x square y and n is equal to x square, right? And we need to calculate for the right hand side del m upon del y. So del m upon del y is equal to x square, del n upon del x is equal to twice x. Now from the equation one, so just write all these value here, and first limits of the x and y. So you can see here that limit of x is 0 to 1 because x is moving like this one, so your x limit is 0 to 1, and y limit, so there is a y is moving vertically, so here on x-axis y is 0, and this boundary region is y is equal to x line. So your y limit is y is equal to 0 to y is equal to x. Now just integrating with respect to y first, then applying limit, and then with respect to x. So your final answer is 5 upon 12. So you will you need to calculate only three things. First m and end, then third del n upon del x minus del m upon del y, then your limits. So this is very simple, that x is going moving horizontally, so 0 to 1 limit, x is moving vertically, so 0, and and there is a line, this line is your y is equal to x line, so y is equal to x limit. Now there is another example also here, and this example is come already have come in your MDU 2019 9, sorry. So apply Green's theorem to evaluate this integral, and the upper half circle is given x square plus y square is equal to a square. So first you can see your figure, then this is your upper half circle, right? And point a0 is here, and radius here will be negative. In the second quadrant x will be negative, so minus a0 and a0, and y is equal to square root of a square minus x square, and limit of x, you can see that minus a to a, because x is moving horizontally, so minus a to a, and your limit of y will be, here y is equal to 0, and y is equal to minus sorry, a square minus x square square root के अंदर, right? So this is your limit of y. Now next thing is m dx plus n dy. So m is your, after comparing on both sides, so you can see that you will get m is equal to 2x square minus y square, and n is equal to x square plus y square. So del m upon del y, del n upon del x. So after calculating these two things, just put the value in the right hand side here, and you will get 2x plus 2y, and after then you will differentiate first with respect to y, then you can see that after applying limit, so 2 minus a to a, x is under root is a square minus x square dx, plus 2 upon 2 minus a to a square minus x square dx. So this integral value is being 0, and why it is it why it is 0, because this is your odd function, right? So minus a to a fx dx is equal to 2 times of 0 to a fx dx if fx is even function, and it will give 0 when fx is your odd function. So here fx is equal to x a square minus x square, right? So you can write, you can check here, this function is odd or even, so x is replaced by minus x, so f minus x is equal to minus x a square minus minus x whole square, so minus x square root of a square minus x square, so f minus x is equal to minus fx. Now, fx is an odd function. Odd function is definition is, if f minus x is equal to minus fx, then that your function odd function, and if f minus x is equal to fx, that means even function, right? So you are getting 0 for this one, and only this integral is remaining. So minus a to a x square root of a square minus x square dx is equal to 0, and minus a to a square minus x square dx. So you can this is your even function, so you can break the limits, so 2 times of 0 to a square minus x square dx. Now integrate with respect to x, and your final answer is 4a cube upon 3, right? Now these three questions can be come in 7.5 marks, but verification will be your 15 marks question. So there is a verification question also here. Verify Green's theorem for this integral where c is the boundary, y is equal to x and y is equal to x square. So verification means you will you need to check left hand side as well as right hand side. So both of the side you will check here, and if both sides answer are equal, then your Green's theorem verification is true and Green's theorem is verified. Otherwise your Green's theorem is not true for this that integral reason, and your answer is not matching, so your verification is failed. Right now given boundaries are y is equal to x, so this is a straight line passing through from origin, so this is your y is equal to x line, and y is equal to x square is a parabola, so parallel to y axis, right? Now intersecting point, because both of these curves can intersect each other, so intersection point is x square is equal to x, just left hand side is equal are equal, so you can put right hand side equal, so x is equal to 0, x is equal to 1, and y is equal to 0, y is equal to 1, so 1 1 and 0 0 are the intersecting point. Now for the right hand side, you need to calculate m dx plus n dy. So your m dx means m is equal to this one, n is equal to this one. Right now, next you will calculate del m upon del y. So your del m upon del y is x plus 2y, and del n upon del x is your 2x. Now double integration this one dx dy. So x minus 2y dx dy. Now limits, what are the limits of this? So you will draw a strip parallel to y axis, so this strip base is touching on y equal to x square, so your lower limit is y is equal to x square, and upper limit is y is equal to x, right? So upper side is touching y is equal to x line, so your y limit is y is equal to x square to y is equal to x, and x is moving horizontally, so 0 is here, and this line is x is equal to 1. So bounded region, in bounded region you can see that your limit is x is equal to 0 to 1. Now you can calculate your answer, so just integrating with respect to y first, then integrating with respect to x, so you are getting minus 1 upon 20 as an answer here, right? Right. Now next, left hand side. So for the left hand side, so you can see that your left hand side is a single integration, that means this is a line integral, so you will apply here line integral method. So we know that our line integral method, so this is your figure, and your bounded region is OAO, right? So first you are going through OA, so for OA curve is your y is equal to x square curve, so y is equal to x square means dy is equal to 2x dx, and limit of x will be 0 to 1. So just apply here. So line integral, so xy plus y square dx plus x square dy. So you will put y is equal to x square here, and 0 to 1. So you can see that after integration you are getting your answer 19 upon 20. Now for the line, straight line y is equal to x, that means for the reason AO. So AO line is y is equal to x. So you will get dy is equal to x, and your limit of x will be here 1 and here 0. So your limit of x will be 1 to 0, right? This one. Now just put all this value here. So you are getting after integration, your answer is minus 1, right? This 1 to 0, and this one 3x square, so x square by 3, so 0 minus 1, that will be your minus 1. So your minus 1 is the second answer. Now total line integral will be this for the region OA and for the region AO, so 9 upon 20 minus 1, so minus 1 upon 20. So you can check your right hand side answer is minus 1 upon 20 here, right? And your left hand side answer is also minus 1 upon 20. So your Green's theorem are verified, and left hand side is equal to right hand side, right? So these three are two four questions related to your Green's theorem. These are very important questions and theorem also, so just prepare your all questions, and I will share an exercise related to your Green's theorem in our next video, because today I have already shared two exercises related to surface integral, and related to vector integral. So solve these two exercises, and third one I will share tomorrow, right? Thank you.